Now we've looked at the measure of central tendency, okay? So we've looked at this idea of we give yourself a data set, can you pull out one number that you think best represents this data set? That's the idea of measure of central tendency. But what we also need to think about is spread, as we've seen with the idea of mean, okay? The mean kind of gets attracted towards those outliers. So we need a way of describing how spread out that data is, okay? And one really nice way of doing that is through visualizing it, okay? So what I'm going to get you to do, okay, you should have on here, I think it's page 106, okay? You should have a data set, and then you should have a blank copy of what I've got on the screen, okay? Now what I'm going to ask you to do is literally just fill in, so maybe use the middle line, just with a cross, okay, the temperatures which I've got up here, okay? So for example, there's a 15 degrees temperature, so I want you to draw a cross at the 15. Okay, and there's a 19 degrees temperature, so I want you to draw across at 19. So literally, for each resort, resort A and resort B, I want you just literally to draw across according to each temperature. Okay, so hopefully we should have a diagram that looks something like that, yeah? Okay, so if you're just finishing that off, that's fine. But hopefully you should end up with a diagram that looks like that. So we can start to see a little bit more about where data points are distributed, okay, where data points are spread out. So we've got for resort B, we've got a clustering of data points here, then we've got an outlier over here, and then it's a little bit more spread out for resort A. So what I want to do is I want to emphasize this idea a little bit more cleanly, okay? So what I'm literally going to get you to do now is look at part B, or part 2. It asks you to mark the minimum value and the maximum value. Can you do that for me? So literally just draw a line at the minimum value and the maximum value. Okay, so draw a vertical line at the minimum value and the maximum value.
Both?
For both plots, absolutely. Okay, then once you've done that, can you find the median of each data set and draw a vertical line through the median of each data set? So where's the median for the top data set? 1, 2, 3, 4, 5.
34? No, 33.
I think it's halfway between 32 and 44. So what do you say, Batikon? Yeah, it should be 33 as well. Yeah, so we're happy it's 33. Where's the median for the bottom data set?
27? No, 28.
Yeah, I'd say 28.5 personally.
Yeah, okay.
Yeah, it's halfway in the middle. So what you're literally doing with the median, just chopping the data sets in half. Of course, in this case, you've got them ordered. I've ordered them for you, okay? If they weren't ordered, you would have to order them, okay? Now, can you see that once you've chopped the data sets in half, you've got 5 data points on the left and 5 data points on the right. All I'm going to get you to do now is to halve each of the upper and lower parts of those data sets, okay?
Sorry?
So at the moment, you've split the data sets into 2. So literally where my hand is, I'm literally cutting the data sets in half. So I've got a lower half and an upper half. All I'm getting you to do now, I want you to split it into quarters. I want you to split it into quartiles, okay? So I literally want to find you the halfway point of the lower data set and the halfway point of the upper data set. Can you do that for me?
It's not going to be equal on top.
It should be. So the halfway point of the upper data set will be 20. Look at the numbers. And the halfway point of the upper data set will be 40 for the top data set. Does that make sense? Yeah?
Okay.
And then for the bottom one, it should be 26 and 32. Okay? Now, the numbers which I've just pulled out are known as quartiles, because what I'm literally doing now is splitting the data into 4. Okay? So if I split that, so 4 equal parts, yeah?
Okay.
So I'm splitting it into quartiles, quarters, yeah? So therefore, the lower quartile of the upper data set will be 20, and the upper quartile for the upper data set, for the top data set, will be 40. Does that make sense?
Yeah.
Yeah? And then what would be the lower quartile for the bottom data set? 26. And what would be the upper quartile for the bottom data set? 32. Fantastic. So can you draw a vertical line through those two numbers as well, for the top and bottom data set, resort A and resort B?
32?
For the bottom data set, yes. For the top data set, it's going to be 20 and 40. Okay? Now, why have I got you to do that, do you think? Why have I got you to draw a line through those 4 points, or 5 points technically? So I've got you to split the data up into 4 equal parts. Why have I got you to do that?
To identify the quartiles.
Yeah, so identify the quartiles. So you're happy that each quarter of your data set will be worth 25%. Yeah, so 25% of your data should lie in each of those quartiles. Now, answer me this. If there are outliers in your data set, where will they lie?
The first quartile and the fourth quartile.
Absolutely, the lower quartile, so the first 25%, and the upper quartile, yeah? Think about like heights of people in a population, okay? The majority of people, like the normal height people, should be in those middle 2 quartiles, the middle 50%, 25%, 25%, middle 50%. The outliers, the short people and the really tall people, should lie in the outer 2 quartiles. So what I'm going to do is I'm going to put a box around those middle 2 quartiles. And I'm just going to join the outer 2 quartiles together. So let me illustrate what I mean. This is what I mean here. Okay, so I'm going to put a box around the middle 2 quartiles, in other words, where the best representative data should lie. And I'm just going to join the outer 2 quartiles together because I'm aware that there may be outliers in that data set. Okay? So can you do the same for me?
Sure.
So literally make a copy of what I've done there. So where you've got your lines, your 5 lines, can you connect together to draw a box around your middle 2 quartiles, okay, the middle 50%, and then can you just join together just with a straight horizontal line the outer 2 quartiles? Done that? So literally just do that.
Okay.
Okay? Now what I've got you to draw there is a box and whisker plot, or otherwise known as a box, or just a box plot. Okay? The idea of a box plot is that you should be able to understand the concept of how the data is distributed. Okay? And it's a really nice way of doing it, and a really simple way of doing it, because you're able to see where the majority of your data should be. So you remember I said the majority of your data, or the most representative data, should lie in these middle 50%. Is that okay with everyone? Yeah? So the best representative data should lie in the middle 50%. In other words, where you've drawn a box. Okay? Now you can really easily see, just by the length of that box, how consistent your data is. Does that make sense? Batakan, does that make sense? Good. What did I just say? What did I just say? Well, apparently it makes sense, so how do you know whether it makes sense?
You said it.
Because I said it. What did I say? Why don't you know? Because clearly you were listening. Okay. So are you happy, just to reiterate, the middle 50% is where the best representative data lies. In other words, where you've drawn a box, that's where the best representative data lies. Okay? Now, are you happy that there is one way of describing spread? Okay? There's one really nice way of describing spread. And it's the idea of, sorry?
Describing what, sir?
Spread. So how spread out your data is. Okay? Does anybody know? Standard deviation, we don't look at that in this course though. Does anybody know a slightly simpler one? Range?
Oh, yeah.
Yeah, so what's the range?
It's the maximum value minus the minimum value.
Yeah, exactly. So I'm going to come on to that in just a second. But just for the range, ordinarily the range would just be the higher value, take away the lower value. Yeah? So for example, what would the range be for the top data set, for the result A?
30.
30, because it's 45, take away 15. What would the range be for the bottom data set?
20.
20, okay? Now, you notice the reason why I've done the box plots is because I want to look at that middle 50%. That's where the majority of data lies. That's where I'm less likely to get my outliers. So therefore, if I just look at the spread of the inner 2 quartiles, I get the interquartile range. Does that make sense? Yeah? So the interquartile range. What's the interquartile range for the top data set?
40 and 20.
So it's between 20 to 40, which is going to be
20.
20, 40 take away 20. So the top data set has an interquartile range, so from there to there, of 20. What's the interquartile range of the bottom data set? Good, it's 6, right? Now what can you infer? What can you infer from that? So let's put this in perspective, okay? I was talking here about the temperatures of 2 holiday resorts, okay? Can you answer me this question? Which resort would you recommend and why? So I want you to compare three things: the range, the median, and the interquartile range of each data set. So what do you reckon? Okay, what will the median tell us?
The medium temperature.
So what is a median? Gives it an A.
It's
an
value that lies
average.
exactly in the middle.
Exactly, it's a value that lies in the middle, or it's the average. Okay. So in other words, I could say just by looking at the median, just remind me which line is the median on the top data set. Just point it out to me. Fantastic. Yeah, fantastic. You're happy it's that one there,
Yeah.
right? What's the median line on the bottom data set?
This
Yeah, good, absolutely. It's the one in the middle of those two boxes, right? So therefore, which median is higher? Resort A or resort B?
Resort A.
Resort A, which means that on average, because remember median is an average, on average, resort A is hotter than resort B because the median is higher. Does that make sense?
Yeah.
So the median literally tells you which one has the higher average temperature, okay? So one way of comparing this, just usually using the median, is to say that the resort A has a higher average temperature than resort B. Does that make sense? Yeah? Okay. All right, let's think about range then. So what would the range tell us?
The highest temperature and the lowest temperature.
Good, so it's the difference in the extreme temperatures. So is the range higher for the top or the bottom? So which is higher, resort A or resort B?
Resort A.
What's going on? Good, so it's resort A, okay? So in other words, resort A has a bigger extreme in temperature, right? So it's one day it's really hot and then the next day it's really cold, okay? So it's a bigger difference in temperature compared to resort B. Does that make sense? Yeah, okay. Then have a look at the interquartile range. Now the interquartile range is the one that I really want to focus on. So which interquartile range is bigger, resort A or resort B?
A.
A. Which means that resort A has less consistency in their temperatures, doesn't it?
Yeah.
Because the interquartile range tells you where the majority of your data lies, or the best representative of your data lies. So because the interquartile range is bigger, it means it's less consistent. Is that okay? Does that make sense? Because there's more spread. There's more spread in the sort of best representative temperatures. So can I ask you to literally answer that question? So part 4, okay, part 4, I've got you to draw the box plots in part 3. Part 4, can you write me a little summary of exactly what we've just talked through? Okay, so as a general rule of thumb, when you're comparing distributions, you need to do 3 things, okay? First of all, you need to compare the ranges. So remember, the range is just the difference in extremes. In other words, the highest value take away the lowest value, okay? The bigger the range, the bigger the difference in the extremes, okay? So higher range, difference in extremes is higher. Okay? Next thing to compare is the median. What does the median tell you again?
The average temperature.
The average. Yeah, in this case it's temperature, but in general it talks about the average. Okay? So average is, remember, just the best representative of your data set. Okay? So the higher the average, the higher the best representative is
So
going to
our
be.
answer should depend on the average.
Exactly, and you always need to put it in context. So in this case I was talking about temperatures. Okay? So if you're going to compare the medians, you need to say which one had the highest average temperature. If this was talking about marks, okay? If you were talking about median, you'd be talking about which one had the higher average mark, okay? If you were talking about, I don't know, heights, okay? If you're going to compare medians, you'd be talking about which one had the higher average height. Is that okay?
Yeah.
Yep. Okay, and then the last one then is the interquartile range, okay? Interquartile range, which remember is the difference in the upper quartile and the lower quartile. So upper quartile take away lower quartile, okay? What does the interquartile range tell you?
The quarters.
I like consistency, yeah. Okay, so interquartile range tells you about the consistency of the data, right? So the higher the interquartile range, the lower the consistency. And you can see that on the screen, okay? So literally, the top data set had a massive interquartile range. Those two inner boxes were really, really long, okay? Compared to resort B, where it's much, much shorter, much, smaller, okay? So therefore, I can say that because the interquartile range of resort A was bigger for longer, then therefore it was less consistent. Okay, the temperatures were less consistent. In other words, they were more sporadic. They were more all over the place.